Hi, I'm BrendaEM. I'm going to be doing an unboxing of a Siglent SGD 2042x function generator. And this is supposed to be a 40 megahertz model, but one thing I don't like about this right off the bat is, as far as I know, it will only do square waves at 25 megahertz. So right off the bat, the marketing is a little bit bad, but knowing that it's still at an attractive price point, and I did buy it for price point. I wanted something that was 16-bit. I wanted that, so if I wanted to load in a 16-bit audio sample, if I can't do that and figure out a way to do that, then there'll be less aliasing. And so I do like the ARB feature, and it's also it's not that expensive. And I'm going to be doing an unboxing and just to take a look at it, a first look at it, and then make sure it comes up and everything. And then I'm going to give it a couple weeks and learn how to work with it and how it is to work with in actual use. And then I'll show you how it is going through all the not all the menus, but a fair amount of them. Notwithstanding, I ordered double boxes from Amazon, and you can see that there's almost no extra packing in here. So even I ordered double boxing for hundreds of dollars, they couldn't have given me a little more packing than this. A couple little of those little plastic bags would have made a world of difference. And instead, I ended up with it still ended up with crunch corners, and there's ripples going this way. So this was dropped end on end. So poo-poo to Amazon for your packaging. Anyway, you're supposed to open it here, and so I try not to cut too deeply into these things, so mainly just kind of score it. And also, when I'm because I do have a decent sized knife here, I put my my finger on the edge so it only goes so deep when I do this, because you don't want to slit the top of your manual or scratch the case, or if there was liquid in there, it would be bad. And so we'll take a look at the packaging. So I like this box. So this is double-walled cardboard. I like that. I like cardboard, but this, for an instrument like this, I think this is okay. This is probably polyethylene foam, and so at least it's not polystyrene, which is more difficult to recycle. And oddly enough, when you have old packaging like this, you could reuse this. Unlike styrofoam that breaks up into pieces, gets everywhere, you can actually do stuff with this. I save pieces of this stuff. The cord was just banging around inside the case. I don't really care for that. It's just a standard IEC power cord. It's appropriate size. It's not too thin. It's not too thick. You don't need a huge cord like you would get on a computer for something like this. So inside the box we have a cord. Let's put that down. We have a quick start guide, and let's see, some kind of there's recommended due date for calibration. So apparently has some kind of calibration. So the quick start guide, it's color, glossy. And I guess this is enough to get you started, given a function generator. If you've used a function generator before, then this is enough. And maybe if you didn't, this would be enough so you can kind of Ouija board your way through it. There's some kind of certificate. This may not be an actual there is a certificate of calibration on the back. It's not so evident that there is, but apparently it has some kind of calibration, and so that's nice. That makes me feel good. There's a USB cable, and this is probably not for the ARB portion of it. This is probably for running it for remote. A little flash drive would be cool with this, for to get you all into the whole ARB part of it, the arbitrary waveform generation. There's software you can download on the site, and I don't believe it's included in the box. So we have a USB cable, just a USB printer style cable. And this is a nice inclusion. I think when Dave on EE Blog reviewed his, I don't think they gave him a cable, or somebody else didn't. And let's see what kind of cable they gave and how long it is. I'm not sure why the cable well, actually, the cable would be, you know, it'd be cool is if it had some caps for this. I'd rather have caps that cover up these. And this actually just seems like a decent cable, oddly enough. I mean, for a commercial cable, it still has molded ends, but the coax is pretty beefy. And I see shielding all the way out to the edges, coming through the plastic a little bit. You know, it's doing a little print through thing. And I'm not sure how long it is. I imagine it'd be about a meter. And yeah, it's about a meter. So inside this, we have the polyethylene foam or what have you. And I like this because at least this foam is reusable and it won't get everywhere. So I like that. I was trying to see if this had taken much damage. It's a little rounded here. Tape on here. I don't want to rip holes in the bags because they come in handy. The tape I won't reuse. Nice heavy bag. I like that. And there's got more tape. And if you're not careful with, you know, if you just pull on the tape, you'll rip the bag, and then you have to find a bag. We have a package of silica gel, like that. And sometimes if you're careful, you can bake this stuff, but you have to attend to it, and you don't want to close it inside the oven and leave it unattended. You have to watch it. And let's look at the unit. For the purposes of taking this video, I did remove all the screen protectors from this, and you could see the screen is not like a mirror, but it's still slightly reflective. It's supposed to be a touch screen. Maybe I could get like a matte screen protector for a cell phone or something, install this over this and protect the screen. Of course, you don't want to delaminate the screen pulling it off, and so you have to be careful applying anything and pulling anything off of this screen. It's resistive, so as far as I know, so it should be, you know, it should still work with a screen protector. For comparison, as far as the screens are concerned, you could see that it is a little more glossy, or significantly more glossy than a Rigel 1054Z. The front of the unit itself is probably smaller than you might think, and it's definitely smaller than I thought it was. So it's cute, you know. It's small. This is an American dollar bill. I don't have any other form of currency hanging around here, but the screen is 55 by 95 millimeters, and this is an oscilloscope. It's just a function generator, and so there's not a lot of information depicted at once. There's only like 10 different pieces of information, whereas an oscilloscope, you're basically looking at pixels. So I actually like that it's small and it doesn't take up much space. They actually sell an adapter that you could put this and their multimeter in I think a 2 rack space. So it's like 2 racks high, I think. The buttons themselves, they feel good. They feel good. The encoder, the coder itself feels good. It's a pushy one, so I like that. If you look, you can see how big the buttons are, and I have like average size hands, I suppose. So the buttons are definitely workable. The whole front end of the unit feels really good. We have got a power switch here. It was actually on when I received it, which was interesting. These are the buttons are compared to a US quarter, or the more familiar BNC plug. So if you have really large hands, you might have to be a little careful how you push the buttons. Anyway, you've got two output ports. Rotary encoder. You have control buttons and numerical input buttons. These are like MFD multifunction display style buttons. You've got a little thing for your ARB waveforms. The corners. Actually, I like this feature. This is high density rubber. So if you drop this, it might live. It might. There is a chance it might live, depending on how high and what you drop down, it might live. It likely will die, but it might live. The handle, I guess the handle feels okay. And on this side and on the other side matching this, we have vents. There's a fan on one side, an intake port on the other. You've got something so you can kind of pull this in and out. Like I guess this is what they're thinking, that you could drag it in and out to see it. And in the back we have IEC, it's 50 watts maximum power usage, then the usual assortment of certifications, a serial number, USB, LAN, a grounding terminal, and I like that this is knurled. You've got 10 megahertz in and out, frequency counter, has an auxiliary input output, and I had to look at the manual to see what functions you have through this port, and it says sweep and burst trigger signal input, port of external trigger, sweep burst trigger signal output of external trigger, burst gating trigger input port, and I don't even know what this ASK, FSK, external modulation. Oh, so I guess this is a modulation. This must be AM and FM. A frequency modulation and amplitude modulation through this port, synchronization, and various things you can do. So this is like a multi-function port, and I think the counter might be handy for people who have I don't know, ham radio gear or something, or have other instruments and stuff. I have an old Nixie tube counter that my friend gave me, and at some point I want to hook it up to this, and so that was nice of him to give that to me. But once again, you have the same hard rubber treatment on the back. You can see that the case actually folds into these little tabs here. I haven't given it a first boot up yet, but before I do, I noticed that there's little nubbies under here, and there's little recesses in here, so their particular brand of instruments could be stacked. Oddly enough, I wish there was a standard, like a 16-inch or something, rack standard, or the corresponding metric size, so smaller instruments, which most of them are nowadays, even like really exotic stuff, that you could buy a small rack for small stuff. Let's see how long it takes to boot it up. Nice. And there it's up. So I've got the SGD 2042 booted up, and this is what it defaults to: a 1 kilohertz, 4 volts peak to peak. You might want to watch that. A 0 volts DC offset, phase starting off at 0. The load is set to high impedance. We'll change this to 50 ohm to get a little bit better waveforms. And you can see here that it says output off. This isn't only a status indicator. You can actually turn on the waveform through the touchscreen. And actually, to tell you the truth, I don't like that. I'm not saying it's wrong, but I don't like it. We have hardware buttons over here. I don't feel like I feel a great need to be able to turn it on through the touchscreen. An indicator over here saying whether it's on or off or a status indicator would be fine. I can see how some people might like this, but if anything, then the output should be farther away from basically anything, because imagine if you hook this up to something that was really sensitive, the front end of something or something like that, and you want to set the load to 50 ohms. Now I want to change the amplitude to, like, half a volt or something like that, and then you accidentally turn it on. And I actually accidentally turned this on, and so I wish they would move that away or off, or it's not my favorite thing on this. Anyway, so it's booted up, and then you just turn on the output, and we have a nice sine wave over here on the 1054Z. If you want to change the frequency, there's a number of ways you can actually dial in like this, and I don't often do that. I can see where that could be handy and stuff, but often I know what frequency I want, and I feel the fastest way for me to enter my own frequency is just type it in. So if it's at 1 kilohertz right now, you could push 2 for 2, and then and enter 2 kilohertz, and you can see the waveform has changed. If you want to do like 1 megahertz, and now we've got to change the period on this. frequency on that, and it actually has pretty good waveforms for sine waves. Let's make it a little more challenging. Let's try 20 megahertz. And they still look pretty good. I don't see any crossover distortion, at least at this frequency. Let's try the full Monty, as they say. And at 40 megahertz, oops. And I'm running into the limit of what I can see with this oscilloscope. And at 40 megahertz, with 40 megahertz, it still looks pretty good as best I can tell. But also bear in mind this is a 1054Z. It may have been expanded. Anyway, to change the waveform, we use the waveform button, and we choose square right here. And one of the cool things about this, even though it's kind of a low to mid-end unit, that it can do, it's supposed to be able to do sharp edges even with low frequencies. Let's see what that looks like. I'll set the scale to, it's actually 50 nanoseconds per division, and 20. And some of this discontinuity might be the cable. There might be the limits of what this cable can do. I don't know, because because it doesn't look like quite grabbing overshoot, in that it's a little lump. This could actually be one or more of the connectors affecting the signal like that. This is at 1 kilohertz. Let's try. Let's try. Well, I think the highest theoretical it'll go up is 25 megahertz. But let's try, say, 10 megahertz and see what it looks like there. 10 megahertz. And I was curious to see how much of this might be the oscilloscope and how much might be the function generator. And so I turned on the dot mode. We can see what it looks like at 10 megahertz. And let's change this back to vector. And let's try the full 25. And we'll change it to megahertz. And this probably isn't enough oscilloscope to fairly judge this. I mean, this is a very inexpensive oscilloscope, and its software may have been modified to allow a little expansion, but that's not quite the same as having a 100 or 200 megahertz oscilloscope. If you have one kicking around, and if you want to send it in, I'd be welcome to look at it. Anyway, or accept it. Anyway, so you're going to be limited to 25 megahertz with for SGD 2042x. As far as I know, the faster models, they will do a faster sine wave, but they won't, as far as I know, do a faster square wave. So that's something to consider. So this may not be the thing for doing like RF work and stuff. And at the same time, for a lot of audio stuff and a lot of stuff that you would find around the shop, I think this should do pretty well. I've got it set back to 1 kilohertz, and the other values are fairly the same. And I haven't tried the burst in this, but we can give that a shot. Burst. And let's zoom out and let's see. Yeah, so that's what it's doing. It's putting out just a part of the waveform, and apparently you set off the duty cycle and the period over here. And I haven't used that yet, but I guess that could be handy for just testing, just to see if your stuff can respond fast enough, and or to use it as a triggering pulse. This is interesting. You can actually use different waveforms for the pulse function, so I don't think you're limited to just a square wave. I found out that, as you can see, I'm using a sine wave, an intermittent sine wave here, and let's try some other waveforms with this. A ramp. And yeah, maybe we could even do ARB functions within this. Like, let's try, let's see, we'll go to page 2. And I don't think that's going to do it. Waveforms, noise, ramp. This should be interesting. Noise. Yeah, it can do, to some degree, it can do, let's change it. I don't. I also found that in order to stop some of the higher functions, and so you have to push it again. And now we've been booted back to just a noise, and we'll go back to waveforms and pick sine, and we've got our sine waveform back. So there's a lot of ARB waveforms in this. We can push the waveform button and go to page 2 and click on ARB, and we'll pick ARB type, and we'll use built-in waveforms. And you have, and I'll dial through these, and we can see stair up, stair down, stair up and down. And I'm not going to read off all of these, but you can get a sense that there's a fair amount of common ones. You have math ones. There's 2 pages here. Yeah, you can use these buttons. This is the only time I've used these buttons, so that's pretty exciting. And there's a second page. Under engine, they've got a lot of different other sounds and stuff like radar, and there's 2 pages of that. Window, you've got Hamming windows and different windowing functions and stuff. I'm not sure I'm not sure how I would use that personally in an ARB, but it's nice to know it's there. Trigonometry functions, and there's 2 pages of those at least. And there's more pages. There's this is really strange. They have square waves, and if this thing will actually more or less synthesize square waves, why would you have all these predefined duty cycles inside the ARB memory? I'm not sure about that. That's very curious. You've got medical waveforms, such as if you want to know what like an EEG or a heart rhythm would be like. Under waveforms, I'm surprised there isn't quadrature amplitude modulation under this, just as a software thing. Filter, you've got filters like kind of the roll-off of a Butterworth filter, and I love these guys' names. They had great names, you know. One thing that's interesting is that under waveforms, we go under waveforms, we click on noise, and there's I guess standard deviation, there's mean, but the only thing is there's no pink and there's no white noise. And there's also a Brownian noise or Brownian motion noise, maybe like a natural shot noise or something like that from Brownian movement. I'm not sure, but that would be something good to put in these 3 buttons: standard deviation, mean, white. I would have to do some checking to see whether or not the distribution of these noise would equal to be white and pink anyhow. But I'm surprised there's not a white and pink noise button on here. That's rather strange. Anyway, it's an ARB function generator. You can generate your own kind of white and pink noises and then load them in there. And later on, I'll show you how to do that. This button here lets you switch between the 2 channels, the little tabs there. I like the tab, little metaphor that they use. There's a modulation menu, and I haven't been here yet. This is rather interesting. It almost looks like it looks like they're modulating one sine wave of another, and so there's amplitude modulation, depth, and frequency. I guess that's I don't know if that's the base frequency. I think, yeah. So this is the base frequency. This is the modulation frequency, and I haven't gotten to this yet. And I don't think for the purpose of this interview, I don't think I'm going to do a lot with this and stuff. So this took me a minute to figure out how I was going to trigger from this. But under the waveform menu, if you go over to page 2, there's a DC function. And I've got it set for 3 volts DC. You only have one setting here, offset. And if I turn the output on, and if I go over to my oscilloscope, and you can't see this, and I'm going to force a trigger, you can see I've got 3 volts of DC here. And I don't know if I would use this for like some kind of voltage power supply. 5 volts here, and we'll clear it out, and let's see how high this goes. 10 volts apparently, and actually our output's still on, and we'll force it again on the trigger menu. There we go, and it's about 10 volts. Actually, it says 10.2 volts. And who's to say who's right? I'm thinking the oscilloscope probably is. User interface wise, this is interesting. These buttons here, I don't use them that much. They're supposed to get you across, and I think it'd be cool way to get you across and stuff. But I usually type in the numbers. Oddly enough, I wish there was up and down buttons on this outer edge here and stuff, because I want to go to the next menu thing, but I might not want to. I might not want to use the touch screen, because otherwise you got to go. You're looking in this area. I want to change the amplitude. And let's see, I can't use the knob. I can't use these. And so I've got to take my attention and go down here and say frequency. Here it is, amplitude. Now I can change it. So I wish there were up and down things. This basically if I were setting this up, so if I'm using these things here, I can navigate through here. And if I had knobs here, that would be really cool. So I could just type in this and then move down, type in this and move down. If I want to go to the side, I can do this. And I like the multifunction display. If I walked up to this thing and wanted it and like, ooh, this. Yeah, I get that. I do want the multifunction display. But I want up and down arrow keys here too. So if we push this, it doesn't automatically advance to the next thing. So I still want up and down buttons here. My little project I'm working on, this part of it is, well, the whole thing is going to be kind of, it's a variant on a microphone preamp with, it's going to have a light on it. It's going to be, I have a strange purpose for it. But I'm getting some 60 cycle hum. So I have a high pass filter, and right now this is just made out of old capacitors are kicking around. And oddly, these are have stripes on them. They're old stripe ones. These actually look to be good polypropylene or polystyrene capacitors, and these look like really nice. And they're 1 microfarad each, and of course they're non-polarized. And on the Siglent function generator, I've got the it's set to sweep on this channel, and it's going from 20 hertz to 20 kilohertz. And there's a little thing over here that says if you push this button or toggle this, it will, this little MFD button or multifunction display button, it'll actually turn the auxiliary output trigger on. Although it's a little ADD, I thought I would show you the setup I have here. And so I've got the output coming from the function generator from the back of it into channel 2. And I'm using my probe on channel 1. And if we look at channel 1, I've got AC coupling, of course 10x because I'm using the probe. And channel 2, I'm using 1x because I'm using the trigger. And I've got DC coupling. And for the trigger, if we go over here, you can see that I've got channel 2 selected for the trigger. And it's set for, normal rising edge. And you can see here it's triggering. And you can see here I've got my sweep. And what I want to do, and there's no built-in function on the regular 1054Z for, I want to look at what this is doing at minus 3 decibels down from the top. Or not minus 3 decibels, but from the top of this, I want to see what the frequency is at minus 3 decibels from the top, from the peak. I think that's a little weird is that that decibels for power and decibels for voltage are different. One is a log 10 and the other is a log 20. So that's a thing. This is Audacity. It's a open source and free to download program. And basically it's an audio editing program. It's not specifically made for as a digital audio workstation kind of thing, although you can do multi-track recording with it now. And it's more of a kind of repair the audio, get rid of record pops. And actually, as you can see here, there's a lot of effects, and I don't think I have all of them installed yet. There's hundreds of effects and processes you can use on your audio. It's good for restoration and that kind of thing. And anyway, I loaded in a wave here, and I can click on it. It's kind of a harmonic wave I just found on the internet. And if you hold down the shift key, you can see that the icon changes. And it'll give you an idea of what the wave will sound like if it repeats. Anyway, so You'll notice that the wave is mono, and the wave you choose is stereo. You might have to split it, and you would do that from this menu right here. And there's a split stereo track, and there's actually a split to mono if you wanted to do that too. And you get rid of the offending part if you need to, and keep the part you want. And you can see it's also 44.1 kilohertz. It's 32-bit floating point, but it's not going to be when we export it. And if I zoom in a little bit, if I can find where I'm at, that I tried to make sure the end starts off at the 0 with no offset, and also at this end too. And so I did an effect fade out at the end and an effect fade in at the beginning too. And I clipped it otherwise, but for now we'll just zoom out on. And now what we have to do is grab the insertion cursor and click on Control A for Control All, and it might be different if you're on a Mac. And we're going to click on Export and export selected audio. And you can see right now FLAC is chosen, but I use that for most of my audio chores because the files are small and it's lossless. But for now, we'll click on where it says Save File as File Type. We'll click on Other Uncompressed Files, and for header, it kind of defaults to raw headerless, and the encoding is signed as 16-bit PCM, and now we're gonna change the extension to bin for binary. Oops, bin for binary. There we go, and we're gonna call it bharm, and it's gonna give us a warning. We're going to replace it because I already did this process once before, and I'm tired of seeing this dialogue. Anyway, so we have the file saved. Now we'll start the Siglent EasyWave-X. After the program loads, we'll maximize it. And I'm still working on a technique. I'm not sure if the technique I have is perfect, but I'm trying. I can get the wave into the function generator in some form or fashion. Is it good enough for THD, analysis and that kind of thing? I'm not sure, and I would think that you'd want to do a round-robin check, and to see if what you create is what you get. And but for now, I do file a blank waveform, and we'll give it a 44.1 kilohertz, and we'll use these default samples. I'm going to call this bharm 3, and because I've done several tests of this, and we'll click on OK, and I'm going to go to the file and click on Open, and go down to and change this extension here to bin, and then I'm going to load my exported wave, which is really just a bunch of binary numbers, and we can see that it's in here. So I noticed something about the waveform. If we click on the properties, for some reason the frequency is back down to 1 kilohertz, and I don't know if it's been mangled or not. And but for these purposes, we'll try resetting it to 44.1 kilohertz, and click on preview, and we can see it here, and we'll click on OK. I don't know if we've actually changed it. Let's check it again. It appears that it's still 44.1 kilohertz, and maybe importing it kind of redoes or overwrites the default kind of blank palette I've created. I'm not sure about that. Anyway, we'll click on OK, and if we zoom in on the waveform, which could be done with the scroll button on the mouse, and I don't know how you do it without it. And that's the unfortunate thing, is I could not figure out, if I scroll in, I would like to be able to pan this. I don't see a way to do it. And this might be an RTFM moment, but I've used a lot of even 3D programs. I've usually been able to figure out you know, the panning and translation keys for a 3D program. And so this should, I feel that this should be fairly intuitive too. Anyhow, we scroll in on the wave, and now we look at the other wave in Audacity that we exported. We can see that they're somewhat similar, and I think we need to zoom in a little bit more on this to really get a good view. And so it looks fairly close. It looks very close. You can see we've got double wide pixels here, and the little leading area might be a hair smaller in this. Maybe I had some leading zeros in here, or or maybe perhaps the easy wave considered the first leading zeros to be, you know, not worthwhile, you know, and maybe discarded them. And but the wave looks similar anyhow. Now I'm gonna scroll out, and we can see that it appears to be here. And I'm going to go over here and click on Save As, and its default extension is CSV, and we'll give it a name like B Harm 3, and we'll give it B Harm 3, and click Enter, and we go over here, and here's my other experiments. Actually, here's one of the other experiments, and here is the one we just created. Now I'm going to get Notepad, start Notepad. I'm going to try dragging this in here, and it appears that the frequency is 44,100. So I'm somewhat optimistic at this point that that what we put into it is what we'll get, and it has some little setup parameters, and it has a stream of numbers here. I plugged in a flash drive. As you can see, it's mounted here. It's a 32 gigabyte little flash drive. And I also click on properties here, and looking at the properties, you can see that the file system is FAT32, and I think that's important for devices such as this. If it's an NTFS, or a Linux Mac format or a Linux format, it's probably going to have to be formatted to FAT32, and please be careful doing that. And elsewhere you'll find instructions how to do that. And obviously I'm not responsible if you format the wrong drive, because obviously you don't want to reformat your system disk. And if you need help doing that, or if you need to look up instructions, then you need to do that. Anyway, I've got the flash drive mounted. I'm going to kind of restore this, and I'm going to grab my file, right-click it, and do copy, and right-click and do paste. A lot of times I don't drag stuff around unless I have to, because when I want to copy it, like theoretically, a lot of times when you drag stuff onto another drive, it makes a copy of it. But if I right-click and copy, and click and do paste, or Control-C or Control-V likewise, I always know what's going to happen. But sometimes going from folder to folder or from folder to drive, the result is different. So I always like to know have a consistent result. And so because there's a big difference. The last thing you want to do is drag a folder from point A to point B accidentally, and then sometimes canceling it is worse, and you end up with a big mess that way. You don't want that. Anyway, I'm going to close this window because I'm done here, and unmount the drive. So I have my flash drive, and the function generator is going, and I'm going to put in the flash drive. I always have to check this edge here, find the thin edge, get these guys in here. It's better than breaking the jack, and eventually I believe it'll detect it. But yeah, it took like a full second to detect this. But anyway, we'll go over here to store and recall, and we'll go over here, and we'll click the USB device here, and we'll click here, and once again we have to click file types and state. Now we can see it. That's a little weird. I'd like to see the files without clicking on that button. And we're going to click on our harmonic 3. and it's converting. Who knows what it's doing? Hopefully it's not adulterating our waveform too much. And it has it depicted here. And let's see, amplitude, it's set to 3.4 volts peak to peak. And also remember that voltage and power are different. And let's see, the offset, it's got a little offset to it, and I don't know why. I don't know if that was in the original wave or not, but what happens if we put what happens if we lower this? Let's see, we'll put in 0 here. 0 volts DC. We'll try that, and let's hook this up and see what we have. I've got a cable coming out of the output of 1 into the oscilloscope of input of 2, and for right now I'm using a thinner cable because of the bend radius and stuff, and so there'll be a little bit of signal degradation. This isn't as good a cable as Siglent provided, but for right now I turn on the output, and we can see that the wave appears to be here. And so that looks encouraging. And does it looks like, let's see what's going on. I suspect it's not, there we go. It was getting it sometime, but not others. It's just a trigger thing. And it looks encouraging. And, well, it's an audio wave. Let's listen to it. You can see I've got the output of the function generator going through this sophisticated coupling right here. And anyway, so I had set this frequency to 44 kilohertz. And I turned it on, and I'll raise up the amplifier fairly high. It's 25 watts per channel, so it should make sound. And I'm like, well, what's going on? And what happened was I needed to set this to 1 hertz. And then if I raise it up, I can hear it. It also sounds like it's been resampled and stuff, so that's interesting. Like I said, it'll be interesting to do a round robin. I was thinking about this. So we have our little waveform with our guitar sound on it, and I don't know the exact length in bytes. I don't have to calculate that. And I'm like, is there an easier way to do that, to figure out what proportion of this wave compared to the output frequency? But it turns out there's functionality in this to take care of that at least. So we go over here to store and recall, and right now there's the file has actually been copied to the device. So we can just import it, and right now you can see it says 44 kilohertz, 3 point something volts peak to peak. Let's change the amplitude to 1 volt peak to peak, and if we look over here, it says ARB mode DDS, and we click on ARB mode, we can change the sampling rate. This is cool. This is really cool. We can see right here that right now it's set to mega samples, and so that's not going to come. 16 mega samples a second is not going to help us too much as far as audio frequencies, unless you want to figure out how to make a really ripping fast guitar solo. Anyway, out of one tone. Anyway, we can put 44.1. And right now we can put kilosamples a second, like that. We got 1 volt peak to peak. We have high impedance, which we want because, we're going to load this thing down. And also don't plug these outputs into a speaker. And because the thing is that speakers are inductive loads, and you don't want to do that, because if you hook a speaker up to this and punched it, it would put out probably 100 volts and stuff, and you don't want to put inductive loads on this. So anyway, so we've got 1 volt peak to peak, and this is going to an amplifier and not just a speaker. So this has a fairly high impedance input that doesn't put too much voltage, when it's snooping around and stuff. Anyway, so we'll put on the outputs again, and we can hear our little guitar harmonic. It's supposed to be a B string harmonic. and might be natural, might be artificial, I don't know. Sounds more natural. So this is cool stuff, and you could you could change the frequency and stuff, but as long as you remember to type in 44.1 kilohertz a second or 44,100 hertz, then you'll know that your sample is playing at the right speed. So this is cool stuff. I still want to be able to load a wave into this thing. And what do I think about it? I think overall it seems to be a good device. At least with the oscilloscope that I have, that the waveforms seem pretty good. I don't have a spectrum analyzer. I can't speak to the distortion characteristics and harmonic distortion and stuff, and there's other reviews for that, but at the same time I try to offer a little value added by showing you how to get a waveform in here. Notwithstanding, generally I think it's a good unit for the price. I'm very happy with it, and the build quality is fairly good and stuff. I worry about the edges of the metalwork inside, but the construction, it feels like it's made well. It's an instrument, it feels like an instrument. It doesn't feel like a piece of junk. And I don't know how well it'll hold up over time, but this is, I've only had it for a couple weeks. I had moderate expectations, and actually my expectations have been met and then some. What could be done to make it better? I think when you plug a flash drive in, I would like it to be read even before I start to do anything. If I pull up this unit with a flash drive installed, I just assume wait until you load the flash drive, because it's a little confusing otherwise. I would like to be able to load a wave in here because of the speed of it being 40 megahertz sine wave, 25 megahertz square wave. I feel a lot of people are going to use this for audio usage, and I would like to be able to load a wave or a FLAC. Yeah, FLAC would even be better. Sometimes it's a little confusing to know whether you're on the internally stored stuff or on the flash drive. This is a thing too, but I guess everyone's doing this as far as where this goes. When you're looking at a device or instrument, you also look at your needs and what are you going to do with it. And in this case, I wanted this largely for audio. I had been neglecting, I do Arduino stuff, and I've been neglecting analog audio, and but at the time I still do stuff with analog audio, such as I've been part of a kind of a build team for line array speakers and so forth, and being able to characterize filters and stuff. Having another tool to help me do that is advantageous. Most of the user interface is good. The impedance, someone had said, kind of would like that more on one of these buttons. I like the multi-function display buttons, and it's like I don't want to put my paws all over the screen. It's not going to last forever like that, and so I want to use the hard buttons instead of the touching of the screen. These buttons are fairly small, but I think most people will be able to bang out what they need. These buttons are kind of funny because I don't usually notice them. Interesting. I don't usually notice these buttons. They should not have put a border around here. So and kept it not gray. Anyway, that's the review, and that's the review. Thanks for watching. Please subscribe and watch some videos. If people watch enough of videos, who knows? Maybe I'll get monetized. That also begs the question: when there's so many other channels just like mine that get a lot more traffic, I wonder why.